So we see P naught of e to the j omega will copy this form, right? So we have from here we get e to the minus j L omega P of omega. Right, that's P naught of e to the j omega. Okay? And we have minus. How do I find the form for P naught of e to the j omega minus pi? What do I need to do? I need to substitute omega minus pi into this form, right? So basically, whatever I say omega, we're going to substitute omega with a shift in omega, okay? So I see I will have e to the minus j L and omega minus pi, e of omega minus pi, okay? E to the minus j L omega minus pi, p of omega minus pi equal to 2 e to the minus j L omega. So far, it's okay? All I'm doing here is substituting, the linear phase form into half band condition. And let's simplify, okay? I see that in this side I have e to the minus j L omega, e to the minus j L omega, e to the minus j L omega. Okay? So I'm going to take them out, cancel them out, okay? What is left? What is left is P of omega. This is e to the minus j L omega, which is out. And I have e to the plus j L pi. What is that?
Plus L is also like
Okay, so L is R. E to the j L omega pi will be minus 1, right? Minus 1 give you plus sign. Okay, so I have plus E omega minus pi equal to 2. So here I'm using the property that L is R. Okay, so basically this is telling us how the amplitude response have to be related. So we see that P of omega and the shift have to add to a constant. So let's think about this, right? Let's say P of omega is something like this, okay? This is 0 to 0.4 pi. This is some arbitrary thing, okay? This is pi. So we got P, and we got H. That's it. This is P of omega. How do I plot P of omega minus pi? Let me move this one up. This is P of omega. How do I plot P of omega minus pi? You shift by pi. Okay, so we would have this, which is real. It's going to be like that, right? We shift to pi. We would have that, so on. So this is P of omega minus pi. The sum has to be a constant for all frequency. This is a very strong condition for all frequency. One frequency is easy, right? All frequency is very, very, very hard to do because omega is infinite. Number of omega is infinite, right? I mean, omega is 0 to 2 pi. So take any irrational number. It can be 0.4578, whatever. Okay? So, would this work? With this particular choice, is it valid for this equation? No. You will have, a constant, and then 0 here, and so on. So what does it have to do? Have to be overlapping, right? So I have to bring this to here. Okay? So basically, this will not work. I'm going to erase this and bring them in, right? It has to be overlapping because otherwise you have a 0 here. How much overlap do we need? Right? If this is 0, what do I need here? A constant, 2. This is 2, right? If this is 2, what do I get here? 0. Like that. Right? Otherwise, there's no way to get a constant. And I see that a straight line give me a straight line. The sum of two straight lines be a straight line. All you have to do is figure out the endpoint. So you're going to have a constant, and a constant. Right? Is that clear? So what is the condition on these two quantities? They cannot be arbitrary. Right? Now tell me what is that distance? Because I know that distance is the same as this distance, right? What is that distance? Phi minus omega t. It's right here. Right? It's that guy shifted to there. Right? So you have pi subtract omega t. Okay? So it's saying here that this is pi. No, sorry. This is omega t. Sorry, thank you. This is pi minus omega t. Is that right? Okay, good. Thanks. Okay, so we're saying that omega s has to be equal to pi minus omega t. So conditions are omega s equal to pi minus omega t, or omega p is omega s equal to pi. If 0.4 is the pass band cut off, and 0.6 is the region. And this is 0.3, 0.7, and so on and so forth. They have to be symmetric around pi over 2. Right? And this is why you call half band, because the symmetric point is at pi over 2. So half of the bandwidth, right? 0 to pi is your bandwidth, maximum frequency. Symmetric is at half. That's why we call it half band. The half band try to approximate half the total frequency. When you have third band, fourth band, so on and so forth, you generalize this to 5 over 4, 5 over 3, and so on and so forth. And half band meaning that the pass band is at half frequency. Okay. So now we know how these are related. How about omega p and omega s? Can it be arbitrary? Of course not, right? Because this is again a very strong condition. If you have a peak here, like that, now the filter, right? What do you need over here? Can this such that it will be like this? No. And then exactly the flip. Right? So it has to be the opposite. And so on. So that deviation and this deviation is exactly the same. Right? So you have to have omega p equal to omega s. Again, very, very constrained design algorithm. So in MATLAB, what you can do is you can say E equal to Representations, right? And here is the order.